Hi students, today we are going to discuss a new chapter, periodic classification of elements. In class 9, you might have studied matter is composed of elements, compounds or mixtures. And as we know, elements are the building blocks of matter. And do you know how many elements were discovered till this date? Yeah, 118 elements. Out of these 118 elements, 98 are naturally occurring, making order of chaos, that is the early attempts of classifying elements. When we are visiting a shop, we can see that items, that is soaps, then pickles, then toothpaste, etc. are arranged in a particular shelf. And also soaps of different companies are arranged such that. So, it is easy to select like that. Scientists were classified the elements according to their properties, and that arrangement is the periodic table. So, let us go through the classification, that is the early attempts made by them. So the first attempt made by Antoine Lavoisier. He classified the elements into metals and non-metals, but he couldn't identify metalloids. So this classification is not much useful. Then after that, Dobereiner classified the elements such that a group of 3 elements having same properties. Also, in each case, the atomic weight of the middle element is supposed to be the arithmetic mean of the other 2 elements. See, Dobereiner classified elements in a group of 3 elements. And while he grouping this element like that, he found that the atomic mass of the middle element is the average of the other 2 elements. Let us take an example. Lithium, sodium and potassium. A group of 3 elements in which the atomic mass of lithium is 7 and that of potassium as 39. So, by taking the average as 39 plus 7 by 2 as 46 by 2, that is 23. So, that is the atomic mass of sodium. Like that, he classified elements into a group of 3 elements in which the atomic mass of the middle element is the average of the other 2 elements. And one example for this group is lithium, sodium, potassium. And he named this group as triad. So these are known as Dobereiner's triads. Dobereiner's triads. And see, let us discuss some more examples. Here, the three triads by Dobereiner is given: lithium, sodium, potassium, that we already discussed. The next triads: chlorine, bromine, iodine. And see how the atomic masses of bromine is calculated. Then third one, calcium, strontium and barium. Here also the atomic mass is taken as the average of calcium and barium. So these are the three triads found by Dobereiner. So that was his drawback. So Dobereiner could identify only three triads from the elements known at that time. Next one, Newlands law of octaves. Newland suggested that elements should be arranged in the order of increasing atomic masses. After such arrangement, every eighth element in this arrangement would have same properties as the first element in the arrangement, and which follows the order of musical notes. See, Newlands first arrange the musical notes sa, ri, ga, ma, pa, da, ni, sa, and he arranged the elements in the increasing order of their atomic weight under each musical notes, and he found that the eighth element is the repetition of the first element in properties like the musical notes sa, ri, ga, ma, pa, da, ni, again sa. Okay, so the law of octaves is given when the elements are arranged in the increasing order of atomic mass. The eighth element is the repetition of the first element in properties, and that is what we call Newlands law of octaves. However, this theory could only apply up to the element calcium, after which it failed to hold true for the others. Also, noble gases that were discovered later completely disturbed the existing arrangement. So, as a result, a new arrangement had to be introduced. So, let us discuss Newlands octaves in detail. This was Newlands octaves. He arranged the known elements in order of increasing atomic masses. So he started with the element having the lowest atomic mass, that is hydrogen, and ended with at thorium, which was the 56th element. So he found that every eighth element had properties similar to that of the first one, and he compared this to the octaves found in music. Therefore, he called it as the law of octaves, and is known as Newlands law of octaves. And in this, the properties of lithium and sodium are similar, beryllium and magnesium are similar, boron and aluminum are similar. So it had some demerits. Let us find what were the demerits. First one, it was applicable only up to calcium. That is, as after calcium, every eighth element did not possess properties similar to that of the first one. Then it was assumed that Newlands only by 56 elements exist in nature and no more elements would be discovered in the future. But later, several new elements were discovered and whose properties did not fit into the law of octaves. Then, in order to fit elements into his table, Newlands adjusted two elements in the same slot, but also put some unlike elements under the same note. See, hydrogen, fluorine, chlorine, cobalt and nickel and bromine. Fluorine, chlorine, bromine, as we know, they are non-metals, but cobalt and nickel are typical metals. So, these types of irregularities are there. Similarly, we can find out another irregularities also. And we can say that Newlands law of octaves worked well with lighter elements only. Thank you.